cold, right? Most of the air that we're breathing is nitrogen. If you liquefy it, get it cold enough, it does this. So you can see what's happening is it's boiling off quickly, right? Because the ambient air here is pretty warm for it. So it quickly converts to gas, all right? These are little bottles. This is a 1 liter bottle filled with what?
Water.
Water. Why do you think there's water in here?
Because it's a liquid.
Sure. Well, what do you think is going to happen?
Explode.
Why do I even bother doing it with water? Why not just pour liquid nitrogen in this and see what happens? Why? Just imagine if like you were standing here and I tried pushing you. I'd make you go far, right? Now, what if I pick, who's the biggest guy here? Or lady, the big ladies? But if I push someone much bigger, or if I push a building, what's going to happen? You remember Newton's laws? Well, what's going to happen? Newton's law says for every push, there's going to be an equal opposite reaction, right? So I will be pushed back, right? So in here, instead of just the gas, which you can push easily, we're giving it some mass. And so we're pushing the water out. As soon as I put the liquid nitrogen in here, you're going to see it's going to convert to gas quickly. So that's going to add pressure. When I turn it upside down, that water is going to go out, right? The pressure is going to push that water out. And what's going to happen to the bottle? It's going to get pushed up, right? So we're going to see Newton's laws work here. You ready? So I'll tell you what's happened in the past. We have three different scenarios. One, which is the not fun scenario, is when you turn it upside down, you didn't do things right, and the water just goes. That's not exciting, but we can redo it and get it better. The second scenario is if you don't do it correctly, and which is easy to do. This is not easy, okay? It's easy to goof things up, but if you form an ice plug, this is what we're thinking is happening. We're scientists and engineers, and we're trying to figure out what's done this. And what I mean by this is we've had them blow up. Okay? So it could be loud. So if you're afraid of loud noises, you can put plug your ears, okay? But what we think is happening is, as we're pouring the liquid nitrogen, it's pretty cold, and you can freeze that water really, really fast. And I can show you later, if we have some left over, I'll show you exactly how fast you can freeze water. If you freeze the water and you turn it upside down and it forms an ice plug, and there's no way for that water or the pressure to escape, it starts pushing out on the walls. And this can limit so much, right? It can only tolerate so much pressure before it just goes boom, all right? So there's a chance it might go boom. Don't be afraid, nothing's gonna happen. You might get a little water on you, but that's why I'm wearing this, right?
And we're not.
It's like I was smart.
So we've been refining the method, and it seems, at least for me, with my pour rate of getting it in, you want about a third full of water, and I pour 6 seconds worth at my rate. You see, it might be different for someone else when someone else will do it. Right, let's see what happens. So I'm going to make sure to try to get it to go that way, not your way, okay? So I don't mean to get in front of the cameras or your eyes, but ready? Three, two, one.
Whoa! That was much faster than I was expecting. Give him a round of applause, guys! Woo!
Did it work, though? Crazy, huh?
He did it!
So I'll let my assistants help because I can vouch for them. Unfortunately, I can't let you guys help, but I gave you the recipe.
Shut up fast.
You just have to find the liquid nitrogen.
I don't know where you get liquid nitrogen. Try Walmart.
You can.
So this, he's an undergraduate at University of Florida. No, sorry, Florida Institute of Technology.
That's
he's
Kyle.
working in one of my labs. He's doing a variety of additive manufacturing, meaning 3D printing, sort of cool stuff. So he's here for the summer for about a 10-week internship program. So when you guys are old enough, look into it. And if you guys want to help with STEM sort of events, come see me. We're always welcome volunteers to help with this sort of stuff. Take it away.
All right. So it should take about 6 seconds to pour the nitrogen into the water. So why don't you guys help me out? And when I'm ready, I'll have you start at 6 and count down to 0. Okay? 3. Ready? Okay, start counting.
6, 5, 4, 3, 2, 1, 0.
Negative 1, negative 2.
Now look. Let's show you that experiment that I told you earlier. Let's do away with the water and see what happens, yeah? We'll just reuse this. Let's pour it a little bit. Turn it upside down and we'll see what happens.
The game's still on. I know how to get.
Yeah, you're gonna use a new one. So here, come over here.
Yeah, I know. I know how to go past
Same thing all over again, except now, as Oscar was talking about before, there's no water. So now the gases won't have anything to push against, so it's not going to go anywhere.
That's right.
6, 5, 4, 3, 2, 1. Not as exciting, right? But did you see how much came out? It doesn't take a lot to convert from liquid to gas, right? There's a huge inflow increase of volume, and that's what creates the pressure, which pushes the water out and gets it going.
Right past it. Right
All right, this is my son Marcos now. Now he'll give it his attempt. He's done it
in. You
times too, so he's aware of the
and then I go. Yeah. No.
6, 5, 4, 3, 2, 1.
0.
Quick, quick.
He's almost too slow, right?
Guys, for the record, the liquid nitrogen is negative 321 degrees Fahrenheit. Negative 321 degrees.
That's what I said. Y'all don't listen to me.
That smells.
I want to try.
Do you want to touch this? I want
We do the PPE. Hold on, Marcos.
Can I do that?
Let's see. Well, it's his experiment. Let him try it right away.
Okay.
What's he gonna do now?
Oh,
Just gonna try dropping the bottle. See what happens with liquid nitrogen. No water.
Don't lick it.
We can go. Meanwhile, I'll go get some more water.
I'm gonna back off.
I can't wait to try it.
Carrie, I'd back off if I were you.
Heads up, everybody scoot back. Oh, is it just there's no water in there?
I'm like, well, I think he's freezing water.
Boom.
Dry ice, but it's not.
Yeah,
This
but
is
this is
liquid
liquid nitrogen.
It will freeze your skin if you touch it.
Yes.
So I'm using the likes of the liquid nitrogen.
Jayla, move away. Jayla, move away from that
Theoretically, it should get cold enough
to break.
that it'll be hard. So when I drop it, it should shatter.
Let's use dry ice.
Whoa.
It's plastic.
And that actually did not happen this time.
Stomp on it.
We're gonna go. That was awesome.
We got a lot of water.
Oh yeah. It didn't actually do quite what I expected.
Can we try pouring some of that liquid nitrogen on a branch off of one of these trees?
Or if
They
we
shatter
had
it?
some other, like the donut we used earlier,
I think there's some spare donuts in the kitchen
Or a
there.
rock? If we did it on a rock long enough, then could we shatter the rock?
I don't think so.
Can I pour it? Wait, no, you don't.
Stand back.
Stand back.
Luke's there.
You got the blue gloves on, so you can pick the leaf out of there and throw it down.
So you can see the leaves are actually changing color as they get cold.
Back here, buddy. So
Oh, that's cool. Turn purple.
Which is not what I was expecting.
No.
Is that a pancake?
Yes, it is.
Oh, they're
Oh, that pancake.
ready.
pancakes in there too.
All right, back up, people.
Scoot back. It can hurt your hands. Okay.
Can I have a glove? Can I have a glove?
Hold on, Marcus.
Oh yeah, see that?
Frozen leaves and they're purple too. Oh wow.
Try doing that with the original leaf.
Yeah.
It's just gonna go squish.
Oh.
Yeah, like glass.
Can I try?
Give a good flick.
You don't need the glove. This is fine now. It's not cold.
It is. Can I try?
Careful, guys. Don't put your hand in the bowl.
Okay, don't touch the bowl.
It's turning black again. Can I throw a pancake down?
Is it turning black?
Ooh, I want to throw the cookie down. Why don't you throw the cookie down?
Well, I think the cookie would have done the same thing without the liquid nitrogen in there.
So that's not a hot cake now, that's a cold cake.
No, I'm throwing
No,
it.
yeah, exactly.
That's what I was
The
telling.
cold cake.
Push it.
Look at that shadow, yeah.
That one's got a little bit more density and mass. So
Throw it down quickly.
let's be careful. Exactly. There you go. So you have to be careful with those. Can you do that normally with a pancake?
No.
It goes squish, 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 right?
It started
Look at this. You powderized, pulverized.
Buddy, that's liquid nitrogen. It'll
Processed it.
Can you do it without handlebars? There's a song.
Let's
Says,
put.
I can ride my bike without handlebars.
I did not expect that to be